Whether working in corporate or consulting for clients, I have recognized that analytics ultimately serves two purposes: capitalizing on business opportunities while systematically mitigating business problems. And problems, in my view, comes into one thing: a gap. The gap between what expected and what actually happened. Here's a simple example. You project mass sales to grow 20%. Reality deliver 8%. The gap between the 20 and 8%, that is your problem. And the size of the gap tell you the size of the trouble you're in. And how do we close it? We decompose it. We break this big problem into smaller, solvable pieces. Framework like the McKinsey way or the mental pyramid principle are built around this approach. And every company faces different problems shaped by their resources, the state of growth, the constraints. By working through enough of them over the years, we notice something important. The same type of problems facing again and again, just wearing different consumes. Let me show you what I mean. A retailer distribution of household goods, namely DMSI, operates 3 major distribution centers and additional rented space to serve 438 stores. The current strategy is a full line distribution approach, where all items are shifted from this central hub directly to store or customer. The company is experiencing a 4 to 5 annual growth rate and plan to open nearly 200 new stores by the end. This growth is highlighted the current network is reaching capacity, which leads to inefficient long-haul shipment and increased reliance on expensive third-party space. The business problem is defined by the gap between the current state and the expected future state. On one side, the objective is to minimize the capital operation transition expenditure while maintaining current processing speed and store service level. In the other, the primary financial risks are inflated transition costs driven by split shipment from multiple central hubs. As a result of high cost and inefficiency of current supply chain processing, financial performance and market share has been impacted. Related to industry benchmarks, to close this gap, the companies can decompose this problem into subtasks. First, estimate the exact quantities of inventory needed, a specific regional north to minimize stockout, which triggers to expensive emergency shipments. Second, determine the ideal coordinates for the 4 distribution centers, ensuring the total distance and hence the transition costs are minimized across the entire network. These pain points are prevalent across logistics, retail, e-commerce, warehouse network, and beyond. This issue is immediately common. Looking closely at the exact task, quantity estimation, facility location optimization, performance gets closer. And exactly this kind of recurring transferable challenges that's pattern recognition just across industry. When we zoom out first not, this pattern crystallizes into a finished set of business type that data can systematically solve. Data entry points of 9 data mining tasks. It's one a proven procedure mapped directly to a common business problem type. The primary tool for data-driven solution to business problem is classification, one of 9 data mining tasks we're dissecting today. To see this technical framework functions in practice, we can observe its application to ubiquitous corporate challenge, customer churn. Consider the operational reality of a company A. Going into the fourth quarter, leadership expects stability, reliability, steady retention, business as usual. Nevertheless, actual performance diverges softly from executive expectations. Instead of the anticipated stability, company A's encountered the critical inflection point. A high rate of customers, specifically 20%, systematically assist the platform or decline to renew their contracts the moment they expire. As a result of this pattern, recurring revenue losses and customer acquisition costs dramatically increase, requires to replace the lost volume. Business problem is derived from the gap between the expected strategies benchmark and undesired operational result. Maps again the AARR framework: acquisition, activation, retention, revenues, referral. This issues is immediately visible. Company A has a structural leak at retention phase, and every modern organization runs in the same life cycle. So this is not isolated problem. This is one of the most common problem every company will face. To address this leak at retention phase, the company must shift from reactive tracking to proactive identification. so the goal becomes clear. Identifying which accounts are likely to churn before their contracts expire. When you know source of risk, a team can join with a target retention offer, change the outcome before a fully cancellation even has been. This exact business deployment is where classification steps in. At its core, classification tests process historical data from past customers, analyzing the behavioral pattern of those who left against those who stayed to automatically predict the behavior of active action. This reduces this complex business problem down to the clean binary data mining test, evaluating customer behavior to assign them to one of two distinct classes, churn or retain. Classification is a procedure of assigning individual objects, items, events to specific predefined category based on their underlying characteristics. The tasks rely on two foundational inputs. First, it requires a set of target label with a fixed predefined category or tag available for assignment. In the company A, these are the binary statuses of churn versus retain. Second, it requires features which represent this measurable characteristic or attribute of the objects being analyzed, such as customer constraint term or recent drops in lock-in frequency. Learning from historical data with the outcome already known, the system finds the pattern behind X label and then apply the pattern to new cases. Up to this point, our customer's churn story solely focused on simple choice outcome. Will a customer leave or will they stay? In data mining world, this is the binary classification. It is a straightforward either or decision space. But business reality isn't always binary. Many critical operational problems require mapping data to multiple categories. This is where multi-classification steps in. To see how this played out through financial lens, especially in credit risk assessment. A bank or land institution cannot solely look at a loan applicant and decide safe or unsafe to protect their portfolio and build a well-prepared mitigation plan. They need nuance. They use multi-class classification to categorize applicants to distinct risk level, low, medium, high risk. This granular views allow leadership to anticipate unexpected volatility, price interest rate accurately, and limit the impacts of the future defaults. When defining this target category, one foundational framework I find highly effective to apply MISI, which stands for mutually inclusive, collectively exhaustive. This tool ensures your project scope is completely comprehensive, while keeps this boundary and content strictly defined. Looking at it from practical perspective, it comes down to choose clear content. Mutually inclusive means one individual, one category, no overlap. Collectively exhaustive mean every possible case is covered, no gaps. Together, let's make sure your classification is airtight from the start. Following the first data mining test, one of the most common tests we encounter in practice is regression. To see how it works through a real example, inventory management. Over-ordering leaves the business a full warehouse, luggage of cash, and no room for new stock. This is the pain of the main gap, the distance between what markets actually need and what business plans to hold. And this pain showed up everywhere: logistics, retail, e-commerce, and any organization touching inventory management. To minimize waste and maximize fulfillment, the organization must precisely forecast the demand before it occurs. With a precise finger, inventory managers can stock exactly what's needed. No excess burning through warehouse space, no shortages triggering emergencies orders. And this estimation process is regression. By learning from historical sales data, seasonal trend, and promotion schedule, the system accurately forecasts the precise target value. To be more comprehensive, regression is the process of estimating a specific numerical value beyond historical relationships from different factors. Noted the key distance from classification. Classification answer risk group, churn or retain, lows or high risk. Whereas regression answers how much, a specific figure, not a category. The goal of regression is to predict one target variable that business can act on beyond one or more influencing factors. There are three components going into a regression test. The first is historical data of target variable. Everything business already has in hand: past sales figures, past demand, past outcome. This is the foundation to make estimation possible. The second is factor features, the business variable that experience and domain knowledge how you are likely to drive the target. For inventory, just might be seasonality, pricing, or product category. This comes from knowing your business, not just your data. And the third is the event you already know, such as planned promotion or product launch, can be enclosed as input because the timing is fixed and decided in advance. Due to limited resource, the third component isn't always available. When this information isn't there, the company has choose option, either leaving the factors out or run different scenario or different assumed value and compare the outcome. outcomes. For example, what if we run a promotion versus what if we don't, and compare the results. The output of regressions is the possible future value of target variable. The word possible master here. Regression produces estimate with uncertainty built in, not guarantees, but that estimates are directly actionable. Instead of procurement manager guessing between 2,000 units and 5,000 units based on instinct. Now, the business has a specific figure, say 3,200 units. Rather than everything the historical data revealed, that number try the stocking decision. This is what regression delivers. The key word inside every regression test is relationship. The test runs from input to output by answering the central business question: how the X factor influence the target figure. It starts with the first choose component, historical data, a target variable, and factor features. When the relationships is established from the past, the business apply what it knows about the future into the discovered relationship. The test runs through and return the estimated future figure. While deciding which factors to lead, the most effective approach is to move from macro to micro. Start spot, what are the main forces shaping the demand in the market? Then find it out through business logic toward a specific measurable variable. It's keep the factor lead comprehensive enough to capture the matter and focused enough to remain actionable. Next up is clustering. Another task we encounter constantly in practice. Let's get into it through a real business scenario. A corporate is struggling with physical network. Customers are too far from service points. Transaction costs are climbing, and there are entire high potential markets where the company has no presence. The network wasn't designed for where the business is today, so it's showing up in the cost line. This is one of the most common headaches for any organization managing physical location, logistics, retail, food and beverage, healthcare. The first brain that match the demand. So after digging in, analyzing customer location, running through cost structure, mapping delivery route, what the company needs to do become clear. Grouping the demand points by proximity, and then identify best spot for new facility to see, so that the total distance to every customer in that group is as small as possible. That is clustering the action. But here's the thing, this works on any kind of object, not just for physical location. When zooming out the picture, clustering is the process of partitioning individual item objects location based on their similarity without any specific predefined category set in advance. The part is what makes clustering different everything we've seen so far. No one tells what groups should look like. The data figure this out. Because no predefined category, the goal is simply let the data reveal its own natural structure. Let it show you what groups already exist before you impose any label on them. In practice, clustering serves two different purposes depending on visual and analysis. It frequently is used as the exploratory first step, a way of understanding the shape of the data before deeper analysis begins. It's also used as a standalone final deliverable. Customer segmentation is a good example. The segments themselves are the output that marketing, operation, sales team acts on directly to understand how cluster adjusted that choose core attribute that define how this works. The first is naturality. Clustering is driven by the data itself, not by predefined categories, not by business label someone choose in advance. The groups emerge naturally from the data show. This is what makes clustering generously exploratory. The second is similarity. This is measure how closer two subjects resemble each other based on their attributes. Two things are similar if their characteristics are close. There are two ways to think about similarity. First, at the inverse of distance. The closer two points are, the more similar they are. Second, at the feature comparison. We look at the attribute describing X objects and then identify how so alike the characteristics are. These customers are similar if the age, income, purchase history place them near. When we mapping all characteristics together, how similar is measured depends on what kind of data you're working with and once the similarities are measured, we need threshold. A battery that determines two objects are similar enough to belong in the same group or different one. The threshold is what draws the lines between the clusters. Before moving on, it's worth locking in how clustering different classification, because on the surface they can sound similar. In clustering, actually core gets assigned to predefined class. The category exists before the task begins, and the task learn from label historical example to make that assignment. In clustering, there are no predefined classes and no label example. examples. The tasks look at the data SSA and find the natural growth beyond their similarity and surface the structure was already there, waiting to be discovered. One's answer for which predefined category does this belong to, and the other answer what growth naturally exists in the first place. And we wrapped up the first 3 data mining tasks. The real takeaway isn't about understanding the algorithm. The truth values lesson how we view our everyday operation, and we can actively translate our vague corporate pinpoint into specific data mining tasks. When we can map the business reality to data mining tasks, we unlock the ability to build a real and actionable solution right where we work. I really appreciate you taking the time out of your day to explore this topic with me. Diving into how data map to business strategy is a major interest of mine, and having you join me for the deep dive means a lot. We are only a third of the way through our journey. In the next video, we are going to dissect the next 3 critical data mining tasks to expand the analytical toolkit even further. Thank you so much for watching, and I will see you in the next one. Bye!